On this episode of Adventure in Geology, we will take a look at volcanoes and the really cool rock evidence they leave behind. To get started, we need to understand a little bit about the three primary types of volcanoes and their individual type of eruptions. First, let's start with the tallest of the volcanoes, a stratovolcano, also known as a composite volcano. This volcano is identified by its mild sloping base that gradually gets steeper as the volcano peaks. The shape develops over time as each eruption leaves a new layer of lava, pumice, and volcanic ash. Eruptions from a stratovolcano can be very powerful and explosive. To explain how powerful, when Mount Tambora erupted in April of 1815, the sheer volume of ash and particulates reduced the amount of sunlight making it to the Earth's surface that the following year of 1816 was dubbed the year without a summer, due to the resulting global cooling. The shield volcano is the next type of volcano we will look at. This volcano takes its name from its appearance. It looks like a warrior's shield placed on the ground, and a very large warrior's shield it would be, as this type of volcano can cover an area of tens of kilometers in diameter. To understand how big a shield volcano can be, if you could place a highway straight through Hawaii's Mauna Loa volcano, from one side to the other, it would take 1 hour to drive. Now, for all its incredible size, the shield volcano could correctly be called the gentle giant. When the volcano erupts, it tends to ooze and bubble for a long time, and the resulting lava is much more fluid, allowing it to cover larger areas. Over time, continued eruptions add layer after layer, resulting in the shield's appearance. And the third type of volcano is what you see behind me, Pavant Butte, a cinder volcano. Cinder volcanoes are what you might call the mighty might of volcanoes. The sides tend to be straighter and steeper and with an overall height less than 300 meters. They can be quite small in comparison to the strato and shield volcanoes, but what they lack in overall size, they sure make up for in speed. This type of volcano can appear and grow to full size within a few months to a couple of years. The reason this volcano can appear and grow so quickly is all within its name, cinder cone. As the volcanic vent opens up in the Earth's surface, it blows ash and cinder into the air that piles up around the vent, creating a cinder volcano. Now, when a cinder cone volcano erupts, like its larger sibling, the stratovolcano, it packs an explosive punch. But size does matter. Even though this little volcano packs a serious punch, it just can't compare to its heavyweight sibling, the stratovolcano. Before getting into the specific details of the three stages of volcanoes, extinct, dormant, and active, we need to explain there is no 100% definitive measure. For this reason, we will follow the somewhat loose guidelines of the United States Geological Survey, or USGS as it's known. This particular volcano, Pavant Butte, is an example of an extinct volcano. The USGS tells us that extinct is defined as a volcano scientists consider unlikely to erupt again. Like we said, it's a pretty loose description. Understanding this, we can pretty safely say that Pavant Butte is extinct due to the shifting of the North American plate, along with the rise of the Sierra Nevada mountains, which cut off the magma source, leaving it extinct. The next stage we will look at is a dormant volcano. Of the three stages, this one gives us the best chance of a definitive answer. The USGS defines dormant as not currently active, but could become restless or erupt. And the final stage is the active volcano. Once again, the definition from the USGS is as follows. An active volcano is one currently erupting or showing signs of an arrest, such as earthquakes and gas emissions. As we said earlier, the definitions are kind of loose. Many scientists also consider a volcano active if it has erupted in historic time. Historic time is man's recorded history, but recorded history varies drastically. Recorded Mediterranean history goes back more than 3,000 years, but the United States, our recorded history goes back around 300 years. This 2,700-year gap is a pretty big gap to define active. Let's discuss some features and attributes of volcanoes, such as craters and calderas, magma and lava, lava flows, and lava tubes. First up are craters and calderas. Normally these terms would be discussed separately, but you might be thinking, isn't one the same as the other? Well, you're kind of right. Both are circular in shape and bowl-like, but they are different. In size, the crater is smaller than the caldera. Volcanic craters are usually created by the outward explosion of rock and material during an eruption. However, the caldera is created when the magma chamber of a volcano collapses due to the magma leaving the chamber, or if during an eruption the magma chamber blows itself open, leaving behind a caldera. A point to understand: even though we have described them as round and bowl-like, it doesn't mean that the bowl will stay intact. Sometimes the eruption will literally blow out the top and the side of the volcano, leaving behind a partial bowl. And since we're lumping terms together, what's the difference between magma and lava? To understand the difference between the two, let me share a phrase. Location matters, and it does with molten rock as well. If the molten rock from inside the earth is below the surface of the earth, it's magma. Allow it to escape onto this earth's surface, say through, an eruption, and it becomes lava. There are some chemical changes that happen with the interaction between the molten rock and the earth's atmosphere. But most important is location. Below the crust, it's magma. Above the crust, it's lava. So with the molten rock above the crust and officially named lava, we get lava flows. Lava flows can be a river of lava or like a shopping center parking lot spreading out in every direction. Exactly how far will the lava flow is determined by a number of factors. But most important to understand is the term viscosity. If a particular lava has low viscosity, then it is more fluid, kind of like spilling a glass of water. It goes everywhere and travels pretty quickly. If the lava has high viscosity, then it is more like spilling a milkshake. It's thick and doesn't cover much area or move very quickly. The final feature is the lava tube. It is really exciting to see, but requires specific conditions to occur. First, the type of lava, a fluid lava traveling down a slope or a channel, is ideal. Once we have the right lava, one of the two things might happen to form the tube. If the lava is flowing in a channel, the surface of the lava may cool and create a roof over the channel. When this happens, the insulating property of the cooled lava keeps the underlying lava fluid, allowing the lava below to keep flowing, thus creating a lava tube. The second type of tube is what you see behind me. The lava tube formed inside of a flow, and with a hardened insulated tube, the contained lava can travel tens of miles.